In this video, what we're going to do is just look at rearranging an Kc expression so that we can find concentrations from a Kc rather than finding Kc from concentrations. So we're going to start off in exactly the same way. We're going to write an expression for the equilibrium constant Kc, so Kc equals in terms of concentration, and then we're going to rearrange it. So let's have a go. This is the reaction of nitrogen and hydrogen again in the Haber process. So we're going to do products. Got ammonia, we're going to use their concentration because this is Kc squared over our reactants, nitrogen, multiplied by the concentration of hydrogen cubed. Now, we've been given, in this example, the concentration of nitrogen, which goes here. We've also been given the concentration of hydrogen, which is going here. And we've been given the value of Kc, which is going here. And so we're going to have to rearrange it to say concentration of ammonia equals. So the first thing I'm going to do is I'm going to multiply up both sides by the concentration of nitrogen and the concentration of hydrogen cubed. What the effect of doing that is, if I multiply both sides by it, is they will disappear off the bottom line on the right, and then they will appear on the top line on the left. Now I want to get ammonia's concentration without that squared sign, so I'm going to square root both sides, and I'm just going to reverse it so that the ammonia is on the left. So I'm going to square root both sides, so I'll lose the squared sign from the ammonia. I'm going to put the square root sign over here, and I'm going to have Kc. Everything that was there is now all under my square root sign. And I'm just going to substitute in the values that we were given. So we're trying to find the concentration of ammonia, and we're going to big square root. We have the Kc expression given to us as 2. In fact, all the numbers were 2.0, but we've got to remember to cube the hydrogen concentration. So we're going to put that into our calculator, and we're going to give our answer to 2 significant figures because that's what all our numbers were given. 5.7. You might think, wow, it's going to be tough to work out the units with all those powers and square roots, but remember this is just a concentration, so its units will just be the units of concentration. So what you need to do now is just have a look at this second example, pause the video and see if you can rearrange it to find the concentration it's asking for. The first step is to write the expression for Kc, and then identify what it is you're trying to find. So we need to find this one. Now that's here. So I need to keep that one on the top. I need to move everything else away from it. So I need to rearrange my expression. The first thing I'm going to do is I'm going to multiply by all the things on the bottom line to get rid of that bottom line of the fraction. So there I've multiplied by that bottom line, and now I've got no fraction left. What I'm going to do now is I'm trying to keep this one and get it on its own. So I'm now going to divide both sides by the concentration of water. So there you go, I've divided both sides by the concentration of water. Now all I need to do is plug in my numbers. So remembering, I'm looking up at the numbers I've been given and plugging them into my equation. So we had a Kc of 3.92, a concentration of ethanoic acid of 0.829, a concentration of ethanol as 9 times 10 to the minus 3, and a concentration of water at 0.171. And then you plug all that into your calculator, give your answer to 3 significant figures, and if you do that you should get 0.171, and it's a concentration, so moles per decimeter cubed.